Okay, so I don't know why I didn't do this slide last time. When you have a cycloalkane, then because of we call it strain on the molecule, which basically just means that they are too close together or they want to come apart. So that means they're more reactive than if you have straight chain molecules. Okay, so the next family is called an alkene. So now you have at least one double bond. So normally, the most common is that there is only one double bond. It's not like every single carbon has to be connected with a double bond. There just has to be one. And then the ending is no longer going to be ane, it's going to be ene or ene. And we're going to follow the same rules. So like I said, we're going to still do the longest chain. We're going to still say where the double bond is using the lowest number. So we still have to say where the lowest number, where the double bond starts. And you can have more than one double bond, which is a diene, and more than three would be triene. Again, if you forget the di and the tri, that's okay. Just make sure you say where they are. So which number carbon has the double or the triple bond. Or sorry, double for now. We're going to do triple as well. Okay, so let's do a few practice ones. Okay, so same rules as before. You count the longest chain. So number one is there's only one carbon chain. So 1, 2, 3, 4, 5, which is pent. And then there is one double bond, so that automatically changes the ending to ene, or pentene. And we have to say where the double bond is. Okay, so again, we want to use the lowest number. So when you look, again, this side of the molecule has the double bond versus this side, which doesn't. So then, okay, I think I'm going to start over here. And then this is 1, 2, 3. So technically, a double bond or a triple bond has to be between two carbons. But we always want to do the lowest number. So we're going to say, we're going to call this 2-pentene. And not 3-pentene, right? We always want the lowest number. So it's kind of like the carbon when you go travel down the chain, whichever carbon you hit first that has double bond on it, that's the number you put, okay? Another way that you can do these names when you have to change the ending, so at some point you might have to do it this way, where you do pent to ene. Okay, but for now, we just have done ene so far. You can do 2-pentene. This way, sometimes students like as well, because then the 2 is right with the double bond, so it shows you like what it goes with. But it can be a little bit, that's, maybe not as aesthetically pleasing. Okay, so now this one, you can see there's this extra group here. Then we're probably going to have a branch this time. So when you label branches, they should not have multiple bonds in them. So we're not going to, now this isn't the longest chain anyways, but we're not going to do this. Okay, and call this the main branch and then say that, the main chain and this is the branch. You would never do that, all right? The main chain will always have the double bond in it. So again, you could go 1, 2, 3, 4, or 1, 2, 3, 4, 1, 2, 3, 4. So it's up to you. You can certainly do this, but why? Most people would call this the parent. Now maybe you're used to the group, so you recognize that this is a methyl because it's only got one carbon. Again, when you're looking at the molecule, if I start on this side, then this double bond is going to be at the end, whereas if I go this way, it's going to be at the beginning. And we always, always, always want the lowest number. So go to the beginning. So you're going to go this way, 1 and 3. So 3-methyl, 1-butene. Or again, you could do that's a 1. Yes, Jovan. Yes. Yes, you always want to do the lowest number. So if I went from the right here, then the double bond would be on carbon number 3, like 1, 2, 3. 2 is lower than 3. Down here, if I went from the left, it would be 1, 2, 3. And this way is 1, 3. That's less. Okay, always longest chain, lowest number. Yes. Pardon? Where on carbon number 1, there's a double bond. Yes. So if you don't like this, just do this. Okay? So I put this one here on purpose. So this isopropyl, like I said, it sort of would stand out. So here we have hex, which is 6. Okay? And you decide. So now you can decide, do I want to go left to right? Do I want to go right to left? When you're first doing this, especially, I recommend that you write down which way you're choosing so that you don't screw yourself up and go back and forth. Okay? So let's just do left to right. I'll do the double bond. Oh my goodness, that scared me. I turned it on to silent. Now I forget what I was going to say. I'm going to do the double bonds first. So 1, 3. I don't know why I put a dash there. You can put a comma. It doesn't matter. So on carbon number 1, there's a double bond. Carbon number 3, there's a double bond. Okay? So when you draw the skeleton and connect them at least once, or the parent chain and connect them at least once, then it's easy to go back in and do whatever you, and add whatever you need to. So now this isopropyl, this was this one. Okay? In that chart. So now on carbon number 3, here, connected in the middle of the propyl is going to be this isomer. Okay? So you can decide to put it at the top or put it at the bottom. So you do prop is 3. Yes? We need 3, but connected in the middle. So 1 in the middle, and then 2, 3. Okay? And then go back in and add bonds. Now, when you have this one, for example, there's already 2, so you only need 2 hydrogens. This one has 1, 2, 3. You only need 1. This one has 1, 2, 3, 4. Done. No more. But then we should do these ones. Okay, this one has 3. This one has 2. Okay? So not as common, but maybe you'll see the isopropyl. So that's that shape. You have to look up the shape. Yes, Lauren? Yes. So this is like the hex part. That's this. So those isomers have to be connected to something else. Yes. 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 I can do that. Oops. Yep, that's totally fine. And you can do a mix, whatever. So this one now is a ring, similar with the last example we did for cycloalkanes when there was no beginning and no end. Same thing here. So you'll often see this written as cyclobutene and no number associated with it, because if you go this way, this would be 1. This, like, you'd always count this as carbon number 1 where the double bond was. If you want to put the 1 in, I won't take marks off. Okay, so there are triple bonds as well. As soon as you have at least 1 triple bond, you're going to use the ending YNE. When we get 2 reactions of alkenes and alkynes, then you're going to see that these double bonds can be changed into single bonds, triple bonds into double bonds into single bonds, which makes them a little bit more reactive. We'll talk about that tomorrow. And we're going to do the same thing. Still longest chain, still lowest number. You can have a double bond and a triple bond. You could have double bonds, triple bonds. You could add halogens, whatever. Okay, so we'll do one really easy one and then one weird one. So when this one is prop, right? The first one. And when you have a double or triple bond, you can't have, like you can have methane, right? One carbon. You can't have methene because there's no carbon to double bond to. And you can't have methine. And then when you get to S, then there's only two carbons. So either one of them could be the first one. So the textbook, I think, tries to be tricky and say something about like, why is it just ethene? Why is it just ethine? Prop, even in prop, it has to be on carbon number 1, right? Even if it was written the other way, there's no other option. So sometimes they try to be cheeky, but you can always just write the number. That's on carbon number 1, propyne. Or prop1-ine. Because then in this one, we have, this is an ine, but this is an ene. Right? So now we have to do the double endings. So again, if you look this end, there's the triple bond. On this side, nothing, right? So you're going to start here, 1, 2, 3. So 1 and 3 versus 1, 2, 3, 4, 2, 4. But you can, hopefully, you can start to see that. This is on the left side. There's nothing over here. So start where there is something. Okay, so we have, not probe. 1, 2, 3, 4, 5, pent. And we usually do these alphabetically. Okay, so een comes before ein. So you would say 3 een, 1 ein. If you forget the alphabetical part, I wouldn't take marks off. If you wrote pent, 1 ein, 3 een, that's fine. But you can't switch the numbers. So the numbers tell you what carbon has a double bond. Carbon 3, double bond. Carbon 1, triple bond. Yes? You want to write the parent name twice? The only thing is then it kind of looks like then there's 10 carbons. So you could do this. But you can't write the root twice. Yes. Yes, the double bond. So if you are a cue card writer, then this unit lends itself well to that. You could double bond on the back as een or whatever. There is quite a bit of memorizing here, okay? Okay. So now we can switch to aromatic hydrocarbons. And aromatic hydrocarbons, remember, are based on benzene. So often written like this, sometimes written like this. Okay, but never like this. Okay, not benzene, this is cyclohexane. Not benzene, this is cyclohexene. You have to have alternating. Double bonds. Which in a ring of 6 means there has to be 3. Okay? So not 1, not 2, has to be 3. Most of the time, to be honest, you'll see it like this, okay, with the circle inside. Okay. So benzene, compounds that have benzene are very smelly in not a good way. And so anything that has benzene in it is the parent chain will be benzene. Unless the parent chain is super long, then the benzene can be a branch. But more often than not, the benzene is the parent chain. So the reason we draw it with the circle inside is that the electrons in the double bond sort of spread out. So we can't really tell. Are the bonds like this, this, this? Are they like this, this, this? And we call that resonance, when similar to the polyatomic ions, right? Where they could have a double bond on the top, a double bond on the side. All of the atoms, oxygen atoms usually, around the outside were the same. So then it can shift. So same thing here. So these, the double bonds inside, their electrons can move around as long as it's alternating. Double bond, no double bond, double bond, no double bond. Then so we just draw a circle to try to represent. It doesn't really matter exactly where they are. The fact that it's shared like that makes the molecule very, very stable. So when we do reactions, then we're not going to break the double bonds. We're just going to switch atoms on the benzene ring, but the benzene ring will remain. So again, very persistent, which is not great. This is a very toxic substance. It's an industrial solvent. Not good for us or the environment. Okay, so you can substitute items onto the ring. So the same thing here, you're going to do the parent chain and the group attached. So here, this is one carbon is meth. When you have a branch, we use YL. Same thing, okay? So the benzene ring stands out, and then the branch is attached to it. It is a ring, so technically, yes, that is carbon 1, but if it was drawn like this, this would still be carbon 1. That's a terrible hexagon, but still carbon 1, no beginning and no end, right? Okay, so the rings are sometimes make your life a little easier. Again, if you write the 1, I won't take marks off, okay? This is toluene, so this is the component in some cigarettes and vapes and stuff like that. Very, very, very toxic. Should not be putting it in your lungs. Okay, so what happens if there's more than one group substituted? Because benzene has such a unique set of properties, we give it a unique set of isomer names, okay? So there are 3 possibilities because of the ring. So once you start to go this way, then that would count, could be this way, like you could just flip it. Same thing with here. So there's only 3. There's 1, 2, 1, 3, and 1, 4. Okay, so you don't have to write both. However, your textbook or a test or whatever might say ortho, or it could use the numbers 1, 2. Okay, the groups that are substituted in this picture happen to be the same. They could be different. which we're going to do in the next slide, okay? We'll do another one that's different. So this has 2 methyls, okay? So, and they're on carbon 1 and carbon 2. So you could call this, I'm not going to do the dye, I'm actually going to split it up, okay? So you could call this 1-methyl, 2-methyl benzene. You could call this 1,2-dimethylbenzene. Or you can do ortho. All of these are perfectly acceptable. So again, more memorizing. Why did they do this? It's just because the chemistry of benzene is so unique, okay? It stands out, so they make it stand out. Is that annoying? Yes. Okay, so now you could do the same thing here. I forgot to write 1-methyl, 1,3-methyl. And then I'm out of room, so I'm going to do this one now. Yes. Yes. If you like this, you could do that. You could write ortho-methyl-methyl. I wouldn't take marks off. So your textbook's even lazier. Sometimes instead of ortho, they'll just write O. Sometimes with meta M and para P. I really try hard not to do that, but I think your textbook does. But ortho, meta, and para are only for benzene. So pick a different color. Actually, Okay, so this is a common name. But I feel like your textbook sort of sneaks it into one of the questions. I don't expect you to memorize common names. Okay, we'll talk about what an OH group means tomorrow, but just in case your textbook sneaks it in there. And then, so this is a double substitution where they're not the same. So benzene is the parent chain. This is chloro and this is bromo. So it doesn't even matter, is this carbon 1, is this carbon 4, is this carbon 1, is this carbon 4? That doesn't even matter. So usually we just go alphabetical order, okay? So you can call this 1 bromo, 4 chloro, benzene, or para, bromo, chloro, benzene. And if you so choose, if you prefer dashes, you can put dashes. If you think that keeps your work neater. Okay, so the only weird thing is what happens if benzene is a branch? So let's say we have, and this is so rare, but again, your textbook sneaks it in. Okay, so let's do 9. I'm going to cheat and use my shapes. Okay, so now when benzene is not the longest chain, then so the longest chain is going to be nonane. And sort of in an old school way, if we were going to call benzene a branch, then you might see phenyl, YL like a branch, or benzyl, I think your textbook more commonly uses this, okay? So, but they might, again, they sneak in a phenyl too. So you can call this, it's 1, 2, 3. So 3-phenyl nonane or 3-benzyl nonane. Okay, so the next few slides are just common ones that you don't have to memorize. Trinitrotoluene is TNT, so it's a type of explosive. So again, a very unfriendly molecule. O-cresol is used as a preservative in medications sometimes, again, to make sure bacteria doesn't grow. Cumene is a preservative or a toxin produced by plants to protect themselves from insects. Styrene is styrofoam. So tomorrow when we talk about polymers, then when you break this double bond and link many of these molecules together, like millions, you get polystyrene. Polystyrene is a very persistent molecule because it's based on benzene. It doesn't break down very easily. Okay, so this homework listed here, I don't really know. This is terrible. I would literally cross this out and write down this. So some of it, oops. Some of it I already have here, okay? But if you want all the homework in one spot and you want to write it in that spot on your note, I don't even know. Cross that out, what it says on there, and write this down. But again, some of it you might have already started, okay? The last, if you get burnt out, please don't. The last pages is where it's all mixed together. So it's like properties, and then it's simple ones, then it's multiple bonds, then it's aromatic. This is all of them mixed together. So it's a little bit better there.